guys, so we are still going to be talking about parabolas and quadratics and the relationship between them. So today we are going to be looking at how can we find a maximum and a minimum value of quadratic functions. So we have these different forms for quadratics. This is the form that we talked about in section 2.1. This is called that vertex form. We know that vertex is always going to be this hk value. We also have the standard form, which is ax squared plus bx plus c. What if I gave you this equation? F of x equals 2 times x minus 8 squared minus 8. How do you think you could go about getting that into the standard form if you needed to? How could you get this into standard form? Symmetry?
Solve the x minus 1 squared.
Okay. Do you know what the x minus 1 squared would be, just offhand? If I put it like this, maybe? What's the x minus 1 squared?
X squared minus 2x plus 1.
Good. And then what would we have to do to it?
Multiply 2 the entire.
Okay, so I'd multiply the whole thing by 2 and then subtract 8, right? Because I still have this minus 8. So if I had to write this in standard form it would be this. 2x squared minus 4x minus 6. So these two should be equivalent. Now, I want to prove to you that they are equivalent. And you don't need to be writing this part down. This is just kind of a little extra thing here. So I have put those in my calculator. Here's the standard form of it, and here's the vertex form of it. And now I'm going to do a zoom 6. Here's the first one, and here's the second one. Are they equivalent? Yeah, they're exactly the same graph. So that is a way, if you're asked to write this in standard form, do you see how using the calculator could be helpful to check? It'd be nice, wouldn't it? Because you could always check it. The other thing we have is called this intercept form. Now, I'm going to show you how to take this and put it into intercept form. Here's what I would do. First, I would factor this out. So what's the GCF here, everyone? So I would have 2, and then I'd be left with x squared minus 2x minus 3. Do you guys know how this could be factored? What I put the 2 here, and then what are numbers that multiply to be 3 and subtract to be 2? Good job. So this would factor into x minus 3 and x plus 1. All right? And this is what is called intercept form. We have a coefficient, we have x minus a value, x minus another value. These points here are going to be x-intercepts. We're not talking about that today, that's going to be tomorrow, but that's kind of a preview. All three of these are the same equation. Here's the one that we just found. I'm going to turn this on, I'm going to do a zoom 6. We already know the first two are the same. There's the first one in blue. Here comes the second one that's in standard form. And then we have that third one that's in intercept form. And watch how it's just going to go right over top of it. And so I know that those are 3 equivalent forms of the same quadratic. Okay? Axis of symmetry. This is the line that divides a parabola into mirror images. And it's always going to pass through the vertex. We have a minimum value if a parabola opens up. So what does that mean? What forces the parabola to open up? What would be true of this a value? It would have to be positive. So this is going to happen when a is greater than 0. So the minimum value is going to be the y-coordinate of the vertex if the parabola opens down. Then this is going to be the maximum value. And what forces that parabola to open down when that a value is? Right. Okay, so let's look at some properties here when we have standard form. Now, when we have standard form, it's going to look like this. A can either be greater than 0 or less than 0. We already talked about this. The parabola opens up when a is greater than 0 and opens down when a is less than 0. The graph is going to be narrower than the graph of f of x equals x squared when the absolute value of x is greater than 1. Why is that? What's that going to do if a is greater than 1? It's going to be a vertical stretch. And it's going to be wider when the absolute value of a is less than 1 because it's going to be a vertical shrink. Okay. The axis of symmetry is always going to be x equals negative b over 2a. That got cut off. It's negative b over 2a. That's going to be the axis of symmetry. Here's the reason why. When we have this parabola in this form right here, to find the vertex, it's going to be negative b over 2a. Anybody know what this means, f of negative b over 2a? All right, let's go back up here for a minute. Here's something in standard form. This is A, this is B, this is C. How did I say we find the vertex? What do? We just said it down here. To find the vertex, it's going to be negative. Right, okay, so back up here again. Here's B, negative 4. It's the coefficient of x. So what is negative 4? 4, right? Over, and then I have to do over 2a. So what's going to be 2a? 4. Okay, so then what's the vertex going to be? 4 divided by 4 is 1. Now, how would I find the y value that goes with this 1? Plug it in, right? So I would do 2 minus 4 is negative 2 minus 6 is negative 8, right? What's the vertex of this one? You see that? Okay? All we're doing is we're finding this vertex of this by doing that negative b over 2a. So when we see this f of negative b over 2a, it's just saying to find this, and then plug it in to find y. Okay? So the axis of symmetry is just going to be that value, that x value of the vertex. All this will make more sense when we do some more specific problems. The y-intercept is when we plug in 0 for x, what do we get for y? So look at this. If I plug in 0 for x, what's left for y then? C, right? So that's why it's going to be 0c. All right, let's find the vertex. We're going to go slow on this one so everybody gets it. What's A in this case, you guys? What's B? 8. What's C? Negative 3. Okay? So we have A, B, and C. Now we're trying to find the vertex. So to find that vertex, I have to do negative B over 2A, and then I have to plug it in. I just like to say plug in because writing f of negative b over 2a is a little confusing. So if I do negative b, which is 8, over 2 times 2, which is 4, what is that x coordinate of the vertex going to be? Negative 2. Now, how do I find the y value? Plug it back in. Negative 2 squared is 4. 4 times 2 is 8. 8 times negative 2 is negative 16 minus 3. What's that going to be? Negative 11. There's our vertex. Let's go ahead and find the axis of symmetry. This axis of symmetry goes right, it's this line that cuts that parabola in half. See how it says it's x equals negative b over 2a? Isn't this negative b over 2a? This is just going to be the x coordinate of the vertex. So axis of symmetry, x equals negative 2. Lastly, we're going to find that y-intercept. All you have to do is plug in 0 for x. f of 0. 2 times 0 plus 0 minus 3. What is it? 0 comma negative 3. All right, now, just to prove to you guys that we did all this right, if you're taking a test and this question is on the calculator part, there's no way you should miss it, because you could check your work and make sure that you're right. So I put this into my calculator. I'm going to do a zoom 6. You don't need to put it in, just watch. Here's the graph. Does anyone remember how I find this lowest point? Second trace, minimum. Now, a little thing here though. I can't actually see that minimum, and I need to be able to see it. So what is it that I need to go lower on, the x or the y? The y. The y is not low enough, so I'm going to make it negative 15. So now watch when I hit graph. Don't hit zoom 6 again, because it's going to... Now see how that fixed it? Because I'm going all the way down to negative 15. So now you guys were right. I do second trace, calculate that minimum. Remember how it says left bound, so I go to the left, I hit enter. Whoops, not plus, enter. Oh, darn. Let me go back. So we go to the left, we hit enter, we go to the right, enter, enter one more time, and here's our minimum. Negative 2, negative 11, vertex. Got it? Easy, right? We can do that. Okay, let's go on to the next part here. So, looking at minimum and maximum values, we're going to decide. I'm not going through all this stuff again because I just want to talk about it. If you're the kind that likes formulas, look up here. I am not a formula person. I think it's better to understand rather than write out formulas. So the first thing we're going to do here is find our vertex. So let's write it out. What's A, everybody? B, C. Okay, so now we're going to find that vertex. Find it on your own. I'm going to be finding it up here. After you find the x value, check up here and make sure you have it right. Then plug it back in. Now, I want to do the plugging back in together. Here's what I see people do. They do negative 2 squared. Is that the order of operations? What do we do first? 2 squared and then make it negative. So if I'm going to be doing 2 squared and then make it negative, that's negative 4 plus 8 minus 3. What's that going to be? 1. Now, I like to make a little sketch of this. I'm going to go to 2, 1. Here's my point. If my A value is negative, what does that mean? Are we opening up or down? Down. Do I know the Y-intercept? What's the Y-intercept? Let's go ahead and find that. If I plug in 0 for x, what do we get? Quick, guys. Negative 3. Now look, if I go over 2 and down 3 to get that point, I can go over 2 this way and down 3 to get another point. Just to do a quick little sketch. It doesn't have to be perfect. Now, this says to state the intervals of increase and decrease. Guys, watch closely. Do not zone out right here. This is an important thing. It's the whole basis of calculus, and if you don't get it now, it'll seem really difficult as we move on. If I want to find an interval of what is happening to the graph first, is it going up or down from left to right? Up. So my first interval is an interval of increase. This is always going to be x values. What are the x values that are causing this interval of increase? What are the x values that are causing this interval of increase? Here we go. What are these x values all the way over here? Negative infinity. up to, where do I start changing and moving down? What's the x value? 2. So from negative infinity to 2, I have an interval of increase. That function is going up. Okay? It's going up. What's the next interval I have? What's happening now to the graph? So we call that an interval of decrease. And we're talking about what are the x values that cause my function to decrease? 2 to what? Infinity. Now, why do you guys think I'm not using a bracket around the 2? Exactly. At 2, it's not going up or down, is it? That's where it changes. So I can't include the 2. All right, next, domain and range. What about our x's? Can we use anything? Yep, all real numbers, or negative infinity to infinity. Now, hey guys, let me point this out though. On big ideas, instead of writing the interval of increase this way, they would write it as an inequality. How would I write that as an inequality? These are x's, so I'd have to say what? X less than 2, or even x's to the left of 2, right? All that would mean the same. This would be written as x greater than 2, or x's to the right of 2. Okay. Range. We always go from the bottom up. Bottom up. What's this called down here, everybody? Negative infinity. What do we go up to? Careful, y values from range. 1. You can see how this could get a bit confusing since these are always x's, these are x's, and these are y's, right? Okay, so we got that. If I were writing this in inequality form, I'd say x less than or equal to 1, by the way. And then we have to state the maximum or minimum. So since this is opening down, what are we going to have? Is this going to be a maximum or a minimum? Max. So we're going to have a maximum of 1. That's going to be our highest point. And see how I just wrote the y value? I'm not renaming the vertex. I'm just saying what is my highest y value. Okay? All right, it says to finish 2.21, scroll to extra practice and do numbers 1 and 2 together. I'm going to do one with you, then you're going to do the other one on your own, and you will check it. Here are the extra practice. I'm going to do this one with you because it's the harder one. Label the vertex and the axis of symmetry. So first I'm going to have to find the vertex. So to find the vertex, I'm going to have to do that negative b. So what's it going to become if I have negative b? What's negative b? It's not going to be negative 3. It's negative 3, which is 3. So it's going to be 3 divided by 2 times a. What's 2 times 3 halves? 3. Okay, so then what's our vertex going to be? X value of 1. I have to plug it back in. 1 squared is 1, so I'm going to have 3 halves minus 6 halves minus 2 halves. Why in the world am I doing that? Common denominator as I go. Another name for 3, 6 halves. Another name for 1, 2 halves. 3 minus 6 is negative 3. Minus 2 is negative 5 halves. So here's our vertex. At 1, negative 2.5. All right, is this going to open up or down? Up. I'm just going to find the y-intercept to get one more point. If I plug in 0 for x, what do I get for y? So I can now see that I'm going to have this point, so I have to have this point. Okay? So I'm just doing a real quick little sketch here. So the axis of symmetry is going to come down like this. It's a line, guys. Axis of symmetry. What's the equation of that line? Anybody know? X equals 1 is right. Okay, now do we have a maximum or a minimum? Minimum. Our minimum is what? -5/2, good. Describe the domain and range. I'm going to do this as the way that Big Ideas will do it. Our domain would be all real numbers. Our range would be, they use inequality form, so y is what? Greater than or equal to -5/2. And the last thing, it says to find the function where it's increasing and decreasing. So it starts off what? So I'm going to say it's decreasing. I shouldn't be writing down here. We're doing that tomorrow. It's going to be decreasing to the left. This is the way our book writes it. I like interval notation, but this is the way they write it. So it's decreasing to the left of what? 1? To the left of x equals 1. And it's increasing to the right. Now, again, on our test, I'm going to want this in interval notation. How do I write to the left of x equals 1 in interval notation? -infinity to 1. And then increasing to the right of x equals 1, what do we write? 1 to infinity. Very good. All right, guys, you don't have to do this one. Let's just talk about it just real quick, though. Tell me the vertex. Is it going to open up or down? So what are we going to have, a max or a min? Max. Okay, we're not going to do that one. Okay, so you guys need to do Big Ideas. It's going to be called Section 2.2, Part 1. And that's what you'll need to do.